Hello students, welcome to EPG Pathshala. Today we will discuss about biomedical waste management. The learning objectives include what is biomedical waste and its sources of generation. It will also help you gain knowledge about the different types of biomedical waste. You can understand the steps of biomedical waste management and also understand the proper mode of collecting and segregating the biomedical waste. At the end, we will also look into the risks associated with biomedical waste, its method of treatment and disposal. What is biomedical waste? Biomedical wastes are waste which are generated from diagnosis, treatment and immunization center which involves treatment of human beings and animals. They can be a solid waste or a liquid waste and they pose risk. The infectivity and the toxicity of biomedical waste pose hazard to human beings and animals. That is why its management is very important. Based on the source of biomedical waste, they are categorized into two types, major and minor sources. Primary health centers, medical college, veterinary college, blood banks, biotechnology institution, production units, government hospitals, private hospitals. The waste generated from these units are categorized under major source. Likewise, under minor sources, there are small vaccination centers, psychiatric clinics, funeral services, institutions for disabled persons, all these come under minor sources. Biomedical waste are broadly classified into non-hazardous and hazardous waste. A major portion of biomedical waste are non-hazardous. It is about 75 to 90% of biomedical waste are non-hazardous in nature. It is not risky and it is similar to domestic waste. Generally, these are generated from the administrative and maintenance of hospitals and healthcare premises. Hazardous waste constitutes about 10 to 20% of the overall biomedical waste. They are infective as well as toxic. That is why it poses major hazard to the environment. Hazardous waste are again subcategorized into 7 types. First one, infectious waste. Waste which contain pathogens are called infectious waste. Example, laboratory cultures, waste isolated from wards, tissues, equipments which are in contact with infected patients and their excreta. Second are pathological waste. Human tissues or fluids, example body parts, blood and other body fluids are categorized under pathological waste. Waste which contains pharmaceuticals, example expired medicine, contaminated pharmaceuticals are categorized under pharmaceutical waste. Waste which are specially generated from cytostatic drugs. Drugs which are used in cancer are generally termed as cytostatic drugs. They are categorized under genotoxic chemicals. Waste containing chemical substances, example disinfectants, solvents that are expired and are no longer needed are categorized as chemical waste. Next type of waste are batteries, thermometers, blood pressure gauges, pressurized containers, gas cylinders, gas cartridges and aerosol cans. These are categorized under waste which contain high content of heavy metals. The last type of waste is radioactive waste. Waste containing radioactive substances, example unused liquids generated from laboratory during research, contaminated glasswares, packages, urine and excreta from patients who are treated with radioactive waste are categorized under radioactive waste. This figure shows the different health effects which are associated with biomedical waste. Now, biomedical waste management involves 4 major steps. First is segregation, collection and storage, transportation and treatment and disposal. Now, what is the need for biomedical waste management? As I told you earlier, infectivity and toxicity makes biomedical waste more hazardous and its management is very essential. First, it induces various risks to human health and to the surrounding ecosystem. It leads to environmental hazards, occupational and public hazards. That is why it is very important for proper biomedical waste management. As I told you, biomedical waste management includes 4 steps, out of which the first step is segregation. Segregation is nothing but simple separation of waste into different categories. According to the categories, they are segregated and dumped into a different bags which are color coded. Now, how does segregation help? How does it play a role in proper and safe disposal of biomedical waste? First, segregation reduces special needs of waste handling and treatment. They avoid mixing of biomedical waste along with other municipal waste. They avoid illegal reuse of materials like used syringes, needles and other plastics. It offers a chance for recycling certain components of medical waste like plastics after proper disinfection. Recycled plastic materials can be used for non-food application purpose. The biodegradable waste can be composted and also it can be used for composting purpose. Now, based on the segregation, the waste or the biomedical waste are segregated into 10 different categories. The table given here summarizes the 10 different categories of biomedical waste based on the segregation pattern. Category 1. Category 1 includes human anatomical waste. Category 2 covers animal waste, especially the tissues, organs, body parts, carcasses, bleeding parts, fluid, blood which are generated from veterinary hospitals, colleges and animal houses. Category 3 includes microbiology and biotechnology waste. They are waste which are generated from laboratory cultures, stocks or specimens of live microorganisms or attenuated vaccines. Waste from production of biological toxins are also included under this category. Category 4 includes all waste sharps. Sharps are nothing but needles, syringes, capsules, scalpels, blades, etc. Category 5 includes discarded medicine and cytotoxic drugs. Category number 6 includes soiled waste. Soiled wastes are nothing but items contaminated with body fluids including cotton, dressings, plaster, linens, bedding and other materials contaminated with blood. Category 7 includes waste which are generated from disposable items. Apart from waste sharps, all other items are included in this category, which includes tubing, intravenous sets, catheters, etc. Category number 8, it includes liquid waste, waste that are generated from laboratory washings, cleaning, housekeeping and disinfecting activities. Category 9 deals with ash generated from incinerators while incinerating biomedical waste. Category number 10, it includes chemical waste. All chemicals which are used in the production of biologicals, chemicals and other disinfectants, example insecticides, are categorized under this. Now, let us look into the collection aspect of biomedical waste management. Collection is very important in this particular management. The collection of biomedical waste involves use of different types of containers for different sources of biomedical waste. The containers, bins, they should be located in such a manner that 100% collection is achieved. The bins and bags, they should carry the biohazard symbol which will represent the nature of waste. Figure which is provided in this slide shows what is a symbol that has to be given to a cytotoxic waste and the symbol which has to be given for a biohazard. After collection, the biomedical waste should be placed in a proper place. They should be segregated into different categories and put in respective designated containers. Now, each container should be clearly labelled and they should be kept aside. The reason for labelling is that it may be necessary to trace the waste back to its source. The storage spot always should be on a noticeable area with respective warning signs. The extent of storage should not go beyond 8 to 10 hours in big hospitals, which include almost more than 250 beds, and the storage time should be less than 24 hours. This flowchart provides the color coding for collection of biomedical waste. As shown here, yellow color plastic bags include waste which are generated or which are categorized under 1, 2, 3 and 6. Red color bags contains waste which are categorized under 3, 6 and 7. Blue, white, translucent plastic bags are used for storing waste which are categorized under 4 and 7. Finally, black color plastic bags are used for category waste, which are 5, 9 and 10. Now, after segregation and collection, it is important how do you transport the waste. Transportation plays an important role. The biomedical waste are transported by two ways, either in trolleys or in enclosed wheelbarrows. Manual loading should be avoided as far as possible. The bags or container, they should be tied or lidded before hauling into a different place. Special vehicles should be used so as to avoid contact and direct contact to the transportation operators, scavengers and public. The driver should be trained in such a way that in case of accident, he should be able to attend to the spillage. Now, this figure shows the trolley where the different color coded bins are being carried off. This is a second type of transportation vehicle called as wheelbarrows. Two types of wheelbarrows are there, one is covered and the other one is open. It is always made up of steel and it is provided with two wheels with a handle. Only packed waste, that is in plastic bags, should be carried in wheelbarrow. Care should be taken to prevent the liquid waste from spilling into the wheelbarrow. Now, chutes. Chutes are special type of conduits. They are vertical conduits provided for easy transportation of biomedical waste in case of establishments with more than 2 floors. Chutes can be made of stainless steel with a self-closing lid. The chutes should be sterilized every day with formaldehyde gas. The contaminated linen that are contaminated with blood or other body fluids from each floor must be bundled in a soiled linen or in a plastic bag before expelling into the chute. The figure shows how the chutes are established in a hospital, and alternatively elevators with mechanical winches or electrical winches can be used to bring down the waste containers from each floor. Now, dustbins. Dustbins are again color coded and they are used in storage of biomedical waste. Dustbins should be placed at a specific site so that they do not overflow between each cycle of waste collection. Bins should be cleaned subsequently at each cycle with a proper disinfectant. The dustbins should be wrinkled with plastic bags which are chlorine free and color coded as per the law. Finally, treatment and disposal. So far we have discussed about segregation, we have seen what are the different collection methods, then we focused on transport. Now let's see what are the treatment and disposable methods which are available for biomedical waste management. Before final disposal, the biomedical waste must be disinfected. All anatomical waste can be disposed by deep burial. Syringes to be cut and chemically disinfected with 1% bleaching powder at the source of generation before final disposal into sharp pits. Infected plastics to be chemically disinfected or autoclaved, shredded, recycled and sent for final disposal into municipal dumps. Incineration is one important treatment method in the management of biomedical waste. The method of incineration is to reduce organic and combustible waste to inorganic, incombustible matter. Incineration is done at a high temperature of about 900 to 1100 degrees Celsius. It is a dry oxidation process that results in significant reduction of waste volume and weight. The process is usually selected to treat waste which cannot be recycled, reused or disposed of in a landfill site. Now, what waste can be incinerated or which cannot be incinerated is provided in this slide. Now, pressurized gas containers, hasty chemical waste, silver salts, photographic or radiographic waste, halogenated plastics such as PVC, waste with high mercury or cadmium content, broken thermometers, second-hand batteries, lead-lined wood panels, sealed ampoules or ampoules containing heavy metals should not be incinerated in an incinerator. Now, advantages of incineration is, it provides good disinfection competence. It results in extreme reduction of weight and volume of waste. The residues that is left out after incineration, they can be disposed of in a landfill. It has relatively low investment and operating cost with less skilled person. Now coming to the disadvantages of incineration, there is a considerable release of atmospheric pollutants due to incineration. Also it needs for the cyclic removal of slag and dirt that results from incineration. Inadequacy in demolishing anti-thermal chemicals and drugs such as cytotoxic makes it a biggest disadvantage of this method. Next type of treatment method is autoclaving. Autoclaving of biomedical waste is been popularly practiced. It is used for the purpose of disinfecting and treating biomedical waste. The biomedical waste was subjected to following temperature and pressure based on its residence time. If the autoclave residence time is not less than 60 minutes, the temperature should be less than 121 degrees Celsius with a pressure of 15 pounds per square inches or psi. If the autoclave residence time is not less than 45 minutes, the temperature should not be less than 135 with a pressure of 31 psi. Likewise, if the autoclave residence time is not less than 30 minutes, the temperature should not be less than 149 degrees Celsius with a pressure of 52 psi. While opening in a vacuum autoclave, medical waste is first subjected to a minimum of 1 pre-vacuum autoclave to purge the autoclave with air. Heating may kill the approved biological indicator at the maximum design capacity of autoclave unit. The biological indicator of an autoclave unit is Bacillus stereothermophilus spores. They are called as spore dials or spore strips with at least 1 into 10 to the power of 4 spores per ml. Hence, the temperature must be less than 121 degrees Celsius or a pressure must be less than 15 psi. The chemical indicator strip or tape alters the color which confirms that the respective temperature has been reached. It may be essential to use more than one strip over the waste package at various locations to ensure that the inner content of the package has been effectively autoclaved. This figure shows a large scale autoclave which is used for biomedical waste management. So far we were discussing about the solid waste which is generated from the biomedical waste. Now we look into the liquid waste which is also a part of biomedical waste. Before disposing the liquid form of biomedical waste into a sewer, it must be treated. Pathological waste have to be treated with chemical disinfectants, counteracted and then flushed into the sewage system. The chemical waste should be neutralized with suitable reagents and then flushed into sewer arrangement. This technique needs highly skilled technician for its operation. While handling hazardous waste, substances require comprehensive safety measures. Now, this table summarizes various disposable standards for biomedical liquid waste. The pH of the biomedical waste should be in the range of 6.5 to 9. The suspended solids should be around 100 mg per liter. Oil and grease should be 10 mg per liter, followed by biological oxygen demand and chemical oxygen demand should be 30 and 250 mg per liter respectively. Next type of treatment is microwave treatment. Most microorganisms are destroyed by the action of microwaves at a frequency of about 2450 megahertz and a wavelength of 12.24 centimeter. The infectious contaminants in water with biomedical waste are destroyed by heat conduction when it is rapidly heated by the microwaves. By bacteriological and virological tests, the efficiency of microwave disinfection should be ensured regularly. Biomedical waste should be heated to a temperature of 97 to 100 degrees Celsius by means of microwave in treatment chamber which is carried out in the source itself without shredding. Shredding is a process by which waste is converted into or cut into small pieces. It is suitable for treating most infectious waste with the exemption of body parts, human organs, infected animal carcasses and metal objects. It has a good disinfection competence under appropriate operating conditions and extreme shrinking in waste volume. This process is eco-friendly, although it has relatively high investment and operating cost and potential operation and maintenance problem. This figure shows the various process which is involved in microwave treatment. First, the biohazards are loaded either manually or automatically. The next step is grinding step, which reduces the waste volume. Third, it is heated for sterilization using microwave, and fourth is the transfer of grinded or sterilized waste into a container. Next method, deep burial, is a method of disposal. Dig a pit or a trench of about 2 meters deep, which must be half filled with waste, and cover 50 centimeters of the surface with soil. Covers of galvanized iron wire meshes may also be used. When wastes are added to a pit, a layer of 10 cm of soil shall be added to enclose the waste. Site should be quite impermeable and no shallow well should be found near the site. The pits should be away from the habitation to reduce infectivity of any surface or groundwater. The area should not be in a flooding or erosional zone. The site of deep burial should always be certified by an approved authority. This figure shows a pictorial representation of a deep burial unit. It consists of a bottom clay layer and above which the biomedical wastes are layered, and alternatively it is layered with soil or a soil lime layer. The overall height of the system should be around 2 to 5 meter and the width should be around 1 to 2 meter. The top 50 centimeter should always be covered with a soil cover. Below the soil cover, there should be a cement or embedded wire mesh. Inertization is a process that involves assimilation of waste with cement and other substances before disposal. This will decrease the risk of toxic substances and it will protect the surface and groundwater. A typical percentage of the mixture includes 65% of pharmaceutical waste, 15% of cement and 5% of water. A homogeneous mass is created and cubes or pellets are produced on site and then they are put into suitable storage sites. They are reasonably priced and they are not suitable for infectious waste. Again, based on the treatment and disposal of biomedical waste, they are categorized into 10 groups. Category 1 and 2 talks about incineration and deep burial. Category 3 includes autoclaving, microwaving and incineration. Category 4, it includes disinfection by chemical treatment or autoclaving or microwaving or shredding. Category 5, it includes incineration, destruction and drugged disposal in secured landfills. Category 6, it includes incineration, autoclaving and microwave. Category 7, again it is disinfecting using chemical treatment, autoclaving, microwaving and shredding. Category 8, once again it involves disinfection by chemical treatment and discarding it into drains. Category 9, it involves disposal in municipal landfills. Last, category 10, it involves chemical treatment and release into drains for liquids and protected landfill for solids. To summarize this session, we started by defining biomedical waste, then we looked into its classification which included hazardous and non-hazardous waste. We also discussed why biomedical wastes are important in terms of infectivity and in terms of toxicity. Later, we also studied the level of toxicity of each of these waste. Then we also looked into the various categories of biomedical waste. Then we discussed about the different biomedical waste management aspects which included segregation, collection, transport and treatment and disposal. To conclude, we also discussed about different treatment and disposal options. Thank you.